welcome everyone to the 980th monthly meeting of the Amateur Telescope Makers of Boston. Our speaker is Lisa Grossman. She's a science writer, and she's going to talk to us how we get information and how she does her work and starts the page. To begin the meeting, we want to recognize one person in this audience. Diana Hannigan, she here? Yes. Congratulations to you for your new position as the editor-in-chief of Sky and Telescope. So now for the observing committee and the outreach committee.
Come on, it's us.
Yep.
Wake up, it's summertime. We have some really cool things to talk about, some really cool things to observe. All right, go ahead. Sorry.
What is this?
Well, just make sure in the right place. Where am I supposed to stand? All right, our thought for the day: one gentle dose of starlight to be taken each night just before retiring. That was made by Leslie Peltier. It's good doctor's orders. Instead of taking meds or sleeping aids, just go outside and look at the sky, and you'll be set to go. And next slide.
Sorry.
Oh, that's right.
I gotta work here.
There we go.
This is all Glenn's. This had nothing to do with it.
Astrid may not have been the most senior nor the most eminent astrophysicist working at the Institute, but she was undoubtedly the only one ordered by a small rocky moon. Now, this is also the hell of any grouch that hates the moon. This is their hell, eternally. They'll be walking around, oh, hi Mario. So Mario, you better be a good boy because you're going, every place you go, it's not just 2 weeks out of the month, it's going to be eternally, beep, 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 constantly.
Always a full moon.
Yeah, always a full moon. Okay, let's get to some serious stuff now. We'll let Rich take over. He's the solar system guy.
So I don't know if you've noticed, but Venus is becoming easier and easier to observe in the evening skies after sunset. It's fairly high in the southwest now, so it's pulling away from the sun still. It'll reach greatest elongation east on January 10th, 47 degrees away from the sun. Magnitude minus 4.2. And you know what I'm going to say? Try daytime observations, right? It's pretty bright, pretty easy to find it. Well, sort of easy to find it. But one way to really try and find it is on Friday the 3rd of January. The moon passes only 2 degrees below Venus in the sky. And so the moon is much easier to find than Venus with the unaided eye. So if you can find the moon, there's a pretty good chance you'll actually look up and with your naked eye see the planet Venus. At minus 4.2 magnitude, it's once you see it, you'll wonder how did you miss it 10 minutes ago, because it's actually pretty bright. And I know this is a bit early, but I want you guys to start to think about inferior conjunction coming up on March 23rd. And even with a 1% illuminated disk, the planet will be at minus 4th magnitude. Minus 4. That's still really, really bright. And this inferior conjunction is perfect for daytime observations of that razor-thin crescent. Venus will be 8.5 degrees away from the sun. That's 17 solar diameters away from the sun, which is easy peasy. Right? You don't even have to worry about blinding yourself. You're so far away from the sun, 8.5 degrees. And I encourage you to get out there and carefully find it. A go-to telescope will go right to it. You can use an offset from the sun. You can use alt and azimuth if you have a telescope set up for that. But it's worth the effort. And I encourage you to get out there and try to find Venus in the daytime, especially at inferior conjunction. It's really cool to look at. Big too, because it's close to the Earth, so it's big. It's a razor-sharp crescent. Love it. All right, next slide, please. So Mercury's a morning object now. Greatest elongation west on Christmas Eve, 22 degrees to the west of the sun. But still low in the southeast and a tricky observation. So I'm not even going to get up to look at that. Saturn transits at about 5 o'clock. I don't know if you've noticed, but Saturn's setting earlier and earlier every week, right? And it's harder and harder to observe it. Catch it early while it's still high in the sky. The rings are tilted about 5 degrees. In March, we'll pass through the ring plane, but it'll be really close to the sun and difficult to observe. But a year from now, next November, the rings are going to be almost perfectly edge-on again. So that's coming up later, next year. Neptune is at magnitude 7.8. It's just south of the Pisces circlet. You know, that the westernmost fish in the constellation. Pretty easy to find, actually. It's relatively neat. It's near some nice eighth magnitude stars that you can even see in your finder scope. Uranus is just to the right of the Pleiades cluster. If you catch it in the early evening at magnitude 5.6, again, it's another thing to check out. If you're at the clubhouse, ask us to put Neptune in the telescope. You can see Triton, the big moon of the planet. And with Uranus, the moons are a little more difficult because Uranus is much brighter. You can still see them really well in the 25-inch scope. All right, next slide. So you know I've sent out, yes, sir.
I was looking at Uranus with a small group of people about a week ago. Everyone thought it was a slightly different color.
Oh,
So, I mean, I thought it was a pale blue, but it would be interesting to ask what color they think Uranus
oh, that's a good, sure.
And it's kind of in opposition. Now's a good time to look at it.
Yeah, that's bright. That's check it out. You're right. I've seen it sometimes as a more of a grayish.
Yeah.
I don't see much of the blue.
I thought it was a grayish blue, but some people thought it was slightly yellow. I mean, it was interesting. 5 different people, they all thought it was a different
Wow.
color.
Okay. I'll ask you at the next star party. Jupiter just passed opposition. So if you haven't been out there looking at Jupiter, I know it's cold, but it's between the horns of the bull. Means at midnight, it's local midnight, it's almost straight overhead. Really a great opportunity to view the planet, cloud belts, shadow trends. It's the Great Red Spot. Great Red Spot's actually pretty small these days. It's only about 1 Earth diameter, but it's still visible as a sort of an orangish jelly bean if you happen to catch it at the central meridian. So you know I sent out that email. I've stopped sending out the 19 plus objects, but because I figured you were getting tired of that. But I still think it's important to be reminded of when the Great Red Spot's front and center, when the shadow transits are taking place. So I'll continue to do that until the Jupiter season is passed. But coming up on December 23rd, it's wee hours of the morning. But sometimes the imagers like to get up and that's what it will look like. It's a shot from Sky Safari Pro. I'm showing Ganymede and Io shadow on the planet. Pretty nice, pretty cool to see that. You've all seen the shadow transits before, yes? If someone has not, it's really, again, worth the effort to outbrave the cold and check it out. They're pretty cool. All right, next slide. Oh, I also sent this out because one of the challenges I wanted you guys to think about is to go out and actually look at the disks of those moons. The 4 Galilean satellites, especially in opposition, when they're close, Europa is about 1.1 second. Io is 1.2, 1.6 for Callisto, and 1.8 for Ganymede. See if you can go out, look at those moons, use as much magnification as the seeing will allow, and see if you can actually pick out the disks of the planets. Try to get up around over 200 power and see if you can see them. Mario.
Also, look at the colors. You can actually tell which moon it is by the color.
That's right.
And they're all 4 distinct.
Absolutely correct. That's what I was going to say. Look at the colors. Look at the reflectivity, the albedo. Callisto only reflects about 22% of the light that hits it. It's dark. It's really dark. You can pick them out. You can. Io looks yellow. Talk about sensing colors. Io looks yellow from all the sulfur on it. Callisto is dark. Ganymede is big, and that just leaves Europa. So it's a fun way to add more to your observation.
Yeah, Rich, a week ago, we were at the clubhouse. We were using the 25, but we did have the aperture mask for a while. So we saw a transit. It was just 2 days before opposition. And what was interesting is the shadow was in 2 minutes before the moon. So you could actually see both transit at the same time, which is pretty good.
It's a little hard to see. It's a little hard to see the moons when they're front and center on the disk.
Right.
Because the contrast isn't great, but there's limb darkening. And so when during the ingress or the egress, you can see the moons silhouetted on the disk of Jupiter. And at near opposition, the shadow is, think about what's going on. The sun's behind me, here's the moon, there's the shadow.
Right there.
And if the shadow in a day or two before opposition, the shadow's right next to the moon. And that sometimes helps you to see it.
The week before, I saw it in a 4-inch refractor at home. And it was because it was crossing one of the dark belts.
Yep.
Only because it was crossing the dark belt. It was Europa at the time. It's possible.
John?
I know Jupiter's very bright, but it should be theoretically possible to see the moons with the naked eye.
Yeah, they're like 5th magnitude.
Has anyone ever seen?
I've tried, John, I haven't been able to, I've tried. I put Jupiter behind a telephone wire, you know, as an occulting bar, and I've tried, I haven't been able to.
I did when I was young.
Yeah, these eyes were,
Younger.
Yes.
Yeah,
I tell you, who would be able to do it is our former member Stephen O'Meara.
Yeah.
Another one is splitting epsilon wire
Yeah.
with the naked eye, but
Yeah.
that's keen eyesight.
Tal Montal's daughter
Yeah.
certainly saw them.
Yeah, Tal had a story about
Steve
telling his daughter that they were one way,
Yeah.
and she said, no, they're the other way.
that's awesome.
Wow. Wow.
Yeah, Steve is a former member, by the way. He writes for Sky and Telescope and Astronomy at the same time, and he is eagle-eyed.
When I was a kid, yeah.
He was the first person to see Halley's Comet coming in, he was the last person to see it going out.
It'll be around in 2061, right? Right?
I'll be,
No?
I'll be encased in liquid nitrogen.
So anyway, this is right next to Ted Williams, right? So this is part of your homework, okay? So your homework so far is to go out and look at Venus in the daytime. And now it's to go out and see if you can identify the moons of Jupiter based on their size and the look, their color, if you will. So there are 2 homework assignments. All right, next slide. So just to prove the point, that's an image of Jupiter taken by Sal. And you can see 2 of the
Can I
moons
speak to
there.
this, please?
I'm sorry?
Can I speak to this?
Yeah, go ahead, do it.
Boy, the color rendition is awful, but
It looks better up there.
yeah. So, the point I'm trying to make, this is an image of Jupiter taken through my 6-inch Nexstar 6SE scope. And this is the first time that I have something that kind of looks like I may be able to see the disks of the moons. The one on the left is Io, and that little star below it is a diffraction effect. That has nothing to do with, you know, like a new volcano or something on Io. And the moon on the top is Callisto. So, but this is what I can get with just a 6-inch telescope. The resolution is great. I have a fringe on the side of Jupiter, which I believe is a diffraction effect. You see that fringe? I see that on other people.
Your original picture had way more detail than this shows.
Oh, wait, oh, unbelievable.
Yeah.
Yeah, so the point that I'm trying to make is with a basic telescope and not too much money, the total expenditure here between the telescope and the camera is $869 out of pocket. That's what I spent. The computer was extra. So I had to upgrade to a faster machine so I can get 30,000 frames in a short period of time. I'm not using an ADC or anything like that. This is just straight processing using fire capture, auto stacker, and Registax that's been around for 10 years or so. That's a great program. And Picasso, which is just that simple.
It looks like you can see a surface feature on Ganymede.
It does, doesn't it? Yeah.
Have you tried to identify it?
No, this is the first time that I'm able, so I use the satellites of Jupiter to focus my telescope, because they're nice bright specks. And I go in and out of focus many times until I get it right. But there's some extra diffraction stuff. But the detail in the original images is like,
You can see it up on the screen.
yeah, it's, to me, it's jaw-dropping, but that's, so the point that I want to make is, you don't need a big telescope, you don't have to spend a lot of money, you can actually live in the city, and you can do all this work. That's it.
Amen.
That's it. And by the way, I also have people in the club that have helped me with all this stuff. They've kind of held my hand through all this stuff, particularly Corey Mooney. Where is he?
He's right there.
Okay, Corey kind of got me going at the ground level. John Bedreau and Doug Paul. These guys are giving me as much help as I've asked for, and that's the key.
And just so you know, they sell these things called eyepieces, right? They go in these telescopes, and you don't even need a computer. Heresy. Anyway, yeah, they fit right where that blue thing is. So anyway, Mars, of course, is getting close now to not a great opposition, but an opposition nonetheless. Right now, it's rising about 7:30 in the evening. It's about minus 8.8 magnitude, 10.2 arc seconds, still pretty far away, but opposition comes on the 15th of January, distance of about 60 million miles, with a 14.6 arc second disk, which is only a little bit smaller than the disk of Saturn, just to give you a preview of what Mars is going to look like. The surface details are fairly low contrast, but you should be able to see them. Sometimes you can use filters to help. The polar cap should be, the northern polar cap should be visible. But just to put it on your radar, on Monday, January 13th, there's going to be a favorable occultation of Mars for here in the eastern United States. And roughly 9:25 to 10:41. Times vary, of course, with location, because it's based on the movement of the moon, right? The further west you are, the time's different, right? Just because it's earlier than you see it on the East Coast. So by not much, but it's 30 seconds between first and second contact and third and fourth contacts, and virtually a full moon. So, Mario, maybe that's some reason to get out and look at the moon. Because Mars is, you guys could image that. That would look pretty cool. So that's coming up in January. We'll remind you again, because it's right after the meeting in January. So how about the next slide? What's on the next slide? Still the variable star of the month, T Corona Borealis. I was just talking to Joseph about this. It's coming up now in the morning skies, and he looks at it every morning. Yes, Joseph, where are you? There you go. Every morning, right?
Yeah.
Pretty much, it's clear. I still check the AVSO website to see what people are reporting.
I figure it's better to look at it in the morning because it's more likely you'll be one of the first people to see it.
Yeah, hardly anybody's looking at it, seems.
If you look at the AVSO charts, the data,
About half, but usually I...
pretty few and far between them, they're all in the evening. Yeah.
I have a prediction, by the way. This is kind of morbid, but look in the obituaries and find, if you see anything about my death, go out that night. It'll be an outburst.
That's the day of going to outburst. And for what it's worth, I mean, it's not, it's just something to see. It's just to give you a reason to go outside and look up at the sky, right? We all need a purpose every now and again out there. Cold winter mornings, you're really going to go out there and look at that? Sure, if you really want to see it in outburst.
But again, if I can recommend, since it's in the east around 5 o'clock, if you have an east-facing window, which is what I do, I have an 80mm scope. It's set up there already. I just go upstairs in my pajamas.
Yes.
It's nice and warm. I can look straight through the window, and if I have to, I'll
Yep.
just look at it for 20 seconds to see if it's gone, and if it hasn't, go back again.
Perfect.
Otherwise, I'll let you know.
And you'll let us know, right? All right, next slide, next slide. So the double star of the month, I picked Lambda Orionis. It's the very topmost star in the head of Orion. And it's a really pretty double star if you've never looked at it. Magnitudes of 3.4 and 5.5, 32 arc seconds. It's easy peasy to do. An 08 giant star and a B.5 main sequence star. So there's some nice color contrast there. You can pale blue and a kind of white star. 1,100 light years away. It's a nice, easy to find double.
Bad on my part, I guess, but it's not 32 arc seconds, it's 4.4.
Is it really?
Yeah, and I would have known, it's one that I've looked at before, I'm sorry, it's not that easy, but I wanted to talk a little bit if I may, because I'm the double star guy. He's right about the magnitude.
I'm gonna fact check this.
And maybe I'm wrong, that would be really embarrassing. No, the thing I found interesting about this star, it's kind of a neat star, and some of you remember the old sky and telescopes back in the 1960s. McCall and Mullaney did a thing called the finest deep sky objects, and there were about 105, and counting everything, galaxies, they did a lot of double stars, and that was on their list of 105. I did a thing for Astronomy magazine, the finest 100 double stars in the sky by season, and of 25 double stars visible in the winter sky, I didn't include that one, so I don't know what the story was. But anyway, it's interesting because they're very hot stars, like a lot of stars in Orion are. The primary is like an 08, the secondary is a B0, so they're very hot, very bright. So you would expect when you look through a telescope, you're going to see whitish stars. And when I looked at it, and there's sometimes the human eye plays tricks like Mario's talking about with Uranus, I saw white and blue. It's kind of a contrast effect. But some very skilled observers, I think one was Webb's Celestial Handbook, I think he saw it as yellow and purple. And another one saw it as yellow, and red. These are both astronomers from back in the 1900s, early 1900s. So you just don't know the colors, but it is a pretty pair. What did you find?
Glenn's right, 4.6 arc seconds. So it's a little tougher than 32 arc seconds, but it's a beautiful, beautiful double star. You should check it out.
That's why we're here, because he corrects me if I say something
He
wrong.
fixes what I make.
But so it can be a little tough if you have. I've seen it with a 3-inch scope, no trouble at all. But if there's any turbulence, it might be a little hard to see.
It's just a pretty double. You should get out and look at that. Easy to find, very pretty. All right, next slide, next slide.
Oh,
Oh, this is on you. Go ahead. do
Nova
this.
that wasn't. Now here's where I can screw up, and you can. Oh, I didn't do that.
Uh-oh. What happened there?
Wow.
It somehow hit a different computer.
Oh,
Somebody pressed a button.
You broke it. You broke the internet.
is that why you're not supposed to leave that? Okay, here's an image of it's part of the Veil Nebula, and there are the two parts we're familiar with. This is up above there. I think it's Pickering's Triangle, probably. But anyway, a former member, I got to find his name here.
I'm going to go over here.
Charlie Warwick, I think was his name. Anybody here, was he in the club? Any of you remember Charlie
South
Warwick?
Shore Astronomical Society.
Okay, yeah, I think he
South
maybe,
Shore.
and he's an older member, because I know he got an award, by the way, I think recent Stella fame, the most attendance, I think, he's been to 60 Stella fame, so he's not a young spring chicken. But anyway, this is his picture in the very top. Look at that hot blue-white star. And that caught his attention because there's normally nothing there like that. So he did a little research. And by the way, I'm going to put Sal Rishian in this as well. He emailed Sal about this. He found that it matches this position of AM Cygnus, which is a Meyer-type variable star that varies from about 10th to 15th magnitude. It's rather fourth, and that's definitely right in 15th magnitude. In fact, the stars just on the side of it, they were mid-12s. So something was going on. So he alerted Sal, who alerted me, and I did a little research. I went to the AAVSO website, and I printed out a chart, and sure enough, this thing is really faint. Then I went to the website, to the light curve generator, and it was right at that time, I think the most recent observation was maybe 2 weeks before, it was around 14.2 or 14.3. So what's going on here? So I cautiously called the AAVSO the next day and said, you know, I can't be sure. I was going to look for myself. And it was cloudy, typically. So I just said, maybe something's going, you might want to check anybody that's had any recent observations. And then we just waited, we were on hold, all of us, Charlie, Sal and myself. And they got back to us, Elizabeth Logan got back and said, no, something was wrong probably with the filtering he's used. Now, I'm not an imager, but that seemed to be the problem. And so I just left with this question for imagers, what type of filter would take a 14th magnitude red star and turn into an 8th magnitude nova? I mean, I have no idea.
Infrared leak.
What's that?
You can have an infrared leak.
At that one star?
Yeah, if the star is very red, there's a lot of infrared. And some filters are past infrared when they shouldn't.
Well, you know, this is the one thing, again, some of you have heard me complain about how everything seems to have gone to CCD and the AAVSO, and I was one of their visual observers. So I am a dinosaur, Rich is same thing, eyepiece, that type of thing. But I was just, this whole story is very fascinating. It shows some of the things that happen when you are observers, whether it be imaging or, yes, Larry.
I got the infrared light, everything above 750.
Yeah.
And I'm always amazed that on the regular image, which I'm taking, the stars look one brightness, but in the guide scope, which is measuring infrared only, some stars are remarkably faint, you can't see them. Others are remarkably bright, like 3 or 4 magnitudes bright, because they're infrared stars. Okay,
Yeah.
so it can vary widely if you're in the infrared.
So,
Mario, why do you use infrared? Why do you do that?
I have a dichroic mirror, so it reflects everything above everything shorter than 750 I image with. Normally you just dump the infrared. I have that on-axis guider and it allows the infrared light to go through, so you're guiding on the same field that you're imaging. I've never had guiding problems ever since then.
Nice.
Sal.
So what happened with this whole thing, since I was intimately involved with it, we said to ourselves, gee, this thing is 100 to 1,000 times brighter than it's supposed to be. Somebody else should have reported it, right?
That was the thing.
If it's that different. So Charlie, when he was talking to me one day, he had this brainstorm. He says, you know, My Canon camera has a sensor on it that's a different sensor than the one, he uses an ATIK camera, ATIK. And he says, I'm gonna take 2 images simultaneously. And on the Canon camera, he didn't see this brightness, so he said it was a false positive. It's a false positive, so he reported that the camera caused a false positive to the AAVSO, so I commend him for doing the right thing.
Yeah, it's a filter, you gotta watch with the infrared.
Yeah, so anyway, that's what happened, and we were saying, wow, look at that.
Look at those 2 pictures, that's what I'm talking about.
Yeah, so there's a difference. See that?
If you want to check this out for yourself, this is Pickering's Nebula in the Vale. It's between Eastern and Western Vale. If you want to go find that for yourself.
Is that anywhere near Vail, Colorado?
It could be. Some nights it is. Later in the night. For us, it's later.
And by the way, I finally, because I do trust the Retina over CCD chips, I did check it out for myself when we finally had some clear skies, and it was terrible seeing, and I'm using a 10-inch scope, and with some moderate light pollution, I saw it was fainter than a 13th magnitude field star, so it was definitely down. They still think it's possible it could be a symbiotic type star, which is a type of dwarf nova that's usually associated with red giants. There's that possibility, so they're going to kind of keep a watch on it. Anyway, we want to get going here. I know our guest speaker is doing a little bit of knitting, and by the time we're done, she'll have done a whole sweater. I'm an extra large, okay?
Go ahead, go. You wanted to go through
Okay, we want to go through these kind of fast. This is where, I was the one that blew this. I forgot to send Rich the slides, so just going to go through very quickly. The October object of the month, the Cheer Observing Challenge, is Messier 2, which is a globular cluster, 6 magnitude globular cluster in Aquarius. We'll just go through the slides here. And we're not going to have the people who took the pictures talk about them, because they'll do that for the next one coming up. But first of all, Dave Wilbur, this is with a CSAR 550. And there is obviously some resolution there, and that really impressed me because that's a 50mm lens. And I've never been one to get into astro imaging, but I'm kind of looking at this. This might be a fun thing to get one of those scopes. They're only about $500, I think, and just
$450 on sale.
$450 on sale before they come from China. There's going to be a 20% tariff on China. So get them now. All right, but look at that. That's again. Well, we'll go on. Here's Doug Paul's image.
Nice. Should I go look?
And again, that's 50mm. Doug's is 6 inches.
6-inch scope.
And then we have Mario. Look at the difference, by the way. We'll go back and forth between these. Go ahead to the next one. It's the same, they're pretty much the same. There's the center, there's that field star. Let's back it up again.
Going back?
Yeah, go backwards. Right, there's 50mm. Next.
6 inches.
Oh, 6mm. There's 32 inches. So you see a few more stars.
That's brighter than the moon.
And no complaints. Okay, next.
Size matters.
Lens?
I
Yes.
think there's also a difference in the amount of compression that is being used between those 2 images, so it's, yeah, there's more going on than just the aperture.
That's CCD talk. Usually for visual observers, how old are your eyes? And my eyes are too old. This is just a sketch I made with a 10-inch reflector, and there's a little bit of modeling there. Again, there's that star out there, and I'm working with magnitude 5 skies, so there is a little bit. I'm sure I could have seen more if I were up in Maine. Anyway, next slide. We're supposed to go through these fast. Venues, picture. What scope did you use?
C11H.
Okay. And then we just had a comparison. This didn't show too well in the picture, but one of the challenges was to see that there was like a lane going through. And here it is in the Roger Iverson made a sketch. There it is right there. And Mario's image caught it right up in that area right there. So it is visible both through imaging and through the visual, through the eye. Now let's go to the one for, I think it's this month. And our current challenge, one from last month that we're reviewing now, was the Deer Lake group, which is near NGC 7331. This is, I think, like a 9th magnitude galaxy. These guys are all 13th and 14th magnitude and very small. So let's look at the images, and then any of you that took a picture, give us a brief account of what you did. The first one is Mario's, so floor is yours.
That's, I think about 4 hours. It's 1 hour each, red, green, blue, and 1 hour of long stacked and processed and picks inside.
Nice.
That right there is an NGC object, by the way. Again, you say, how could that be? But look at M40 in the Messier catalog. It's a double stack. Somehow, we were doing it visually back before cameras were in vogue. saw some type of nebulosity. So that's actually an NGC object. And these again are all about 14th magnitude. Now here's Doug Paul.
You see it in Doug's as well. Go back for 1 second.
Yeah, there it is right there.
Yeah, go back in 1 second. Look at the core, and just to the left of the core, it looks fuzzy. I thought I did some processing error and spent an hour trying to figure out why that was fuzzy. Then I looked at the professional photographs, it's real. And I have no idea why that is, unless there's some outpouring of gas obstructing the furthest part of the galaxy. But that's in every image.
By the way, visually, this is pretty much what you're going to see visually.
Yeah, that's the core, but
Yeah.
to the left of the core, there's something going on. You see it in Doug's as well. It's a
It's like
little
it's up
fuzzy
there.
in that area.
No, right in here. But also to the right of the core, there's something going on here.
Oh, yeah.
I circled that little galaxy
So I'm
just to
just
point
pointing
it
out
out.
that's real.
It's almost like the core.
That
The,
fuzziness is real for some reason.
With the Club's 25-inch, I could see the 3 lower galaxies,
You see it in
but
that
not
one
the
as
4th
well.
one.
I tried to research why it's like that, and I haven't really found anything.
And then yours was with the 11-inch, right?
11-inch.
In your photo, Mario, the core looks almost spherical.
Yeah, it's like this
So what if you're
outer
kinda
edge of the core.
What if you're looking
I don't
through
know.
the wall or something and seeing them come?
Now, Doug Aaron is here. Doug, are you on Zoom? Okay, the only thing I remember about this, we'll go back a minute, we kind of went forward, but Doug Aaron's picture was a small scope, that's all I can remember. Okay, but still, pretty impressive for this. I know it was a small instrument, I forget what the size was, but it was less than 6-inch instrument. Next, and these are 13th and 14th magnitude galaxies. This is Dave Hines' pictures. Dave, with us?
Yep, that's
Oh, there you are, okay.
4.5-inch only stone.
4.5-inch.
You have the next picture that finds, I uploaded to Astronomy to identify where the zero galaxies are.
Oh, that's a different one.
I guess you didn't know that.
This is Russell Cox. Is Russell with us anywhere? Okay. Again, what I'm saying is that these are small instruments and you're picking up 13th and 14th magnitude galaxies. Again, imaging, obviously. So we'll go from there. We're going to talk about what's coming up this month. This month's challenge is NGC 891. It's a galaxy in Andromeda. Again, those of you that are old timers remember on Outer Limits, they had a bunch of galaxies when they were doing the closing pictures, and that was one of the ones they had. It's a beautiful galaxy, edge on, very tough visually. I've tried twice now with a 10-inch scope. Again, I'm working with magnitude 5 skies. I think in the old days when I had magnitude 6 skies, I probably would have picked it up, but I had trouble. And yet it's been seen with scopes as small as 4 inches.
It's a surprisingly difficult object visually.
Yeah, it's probably as good as it looks on images.
Yeah.
It's really hard visually. It's a very faint galaxy.
The key is, I think, the core, which is the brightest part of the galaxy, is bisected by this dark dust lane. It's also very big. It's 10th magnitude, but it's 12 arc minutes in length. So that would spread the light out a little bit. So anyway, that's a challenge. And again, please send them in to us. We're now putting these onto the ATMoB website because the Observers Challenge has been discontinued by its co-founder, Roger Iverson. So we kind of picked it up. We're not doing it nationally, globally like they did. It's a club activity because we were really involved with this back when Roger was doing it. So send those things in to me and I'll try to get them on the internet. And what are the challenges? First of all, can you behold the beauty of the topaz and sapphire gem set Almach without being moved to tears? I didn't talk about this. We go back to the slide again, the previous one. Because if you're star hot, which is what I recommend, you're going to start at Almach, which is a beautiful double star, gold and it's kind of like topaz and sapphire. And you just go about 3.5 degrees over and you're there at the silver sliver. So I would recommend, instead of just going right with a go-to and going right that galaxy, start at Almach and the Starhawk. It's a beautiful double. Now, go to the next slide. So I again asked, can you behold the beauty of that double star without being moved to tears? I didn't put it in, but can you be bored to death looking at a fuzzy patch of light with 891? But I didn't want to dump on Deep Starhawk. Steve loves those fake fuzzies. But can you glimpse it with an aperture less than 8 inches? And I'd say, if you're out in the country where you can see 6 magnitude stars, give it a try. It has been seen with 4 inches. I couldn't find it with a 10-inch scope where I live. Maybe the 25 inches above.
Maybe.
And what is the smallest aperture to capture that dust lane? Okay, next slide. And just to start, put a little preview, those who want to get a head start, the January one is a mission nebula called NGC 1491. I think it's the fossil footprint nebula. And I could not see a fossil footprint, but it kind of looked like my tracks in the snow, and that would make it a fossil footprint, I guess. So
Put your foot up there and let's see.
yeah. Okay, but anyway, that's the one for January if you want to get a head start. So right now we're looking at 891 this month. If you want to get a head start, if you've already seen 891 and send me the pictures, then we'll go for that one in January. And the next slide, there should be one more. Coming next month, Introduction to the Winter. Well, we had an autumn night sky at the clubhouse. It was for beginners, but also any of you experts that have been away for a while and want to get a refresher course. And we had 20 people show up. It was kind of a nice session. So we're going to do the same thing. We picked the date of Friday, January 24th. It's a dark moon night. And it's kind of in the middle of the winter. We didn't want to start too early. We give those constellations a chance to get up higher in the sky. Rain dates are the next day. That's a Saturday, the 25th. And then the next weekend, Friday the 31st and Saturday, February 1st, we'll be at the Clubhouse Observing Field. There will be something coming out. I think that's it. You've lost your voice because you had a cold. I'm starting to get hoarse. Is the sweater done yet?
It's all set, yeah.
Okay.
I think that, so that's the
that's it.
observing report, right?
This is where I sit down and
You can
take
sit
a-
down, I have a few more minutes to go with the
Okay.
outreach.
Hey, thank you all.
Nice job, Glenn.
Yeah, Merry Christmas, Happy New Year, Happy Hanukkah. Keep working out.
So let me introduce our speaker. The talk title is From Stars to the Page. Our guest speaker and astronomy writer Lisa Grossman will walk you through her process of writing a news story from pitch to publication. Along the way, she will discuss scientific journal publishing, the difference between press releases and news stories, and how she balances scientific details and compelling story elements. Lisa Grossman is an award-winning science journalist based on the Boston area. She is a staff reporter at Science News and she covers astronomy. She holds a degree in astronomy from Cornell University and a graduate certificate in science communication from UC Santa Cruz. Bring up your slides.
All right, hi. I am messing up, I didn't mean to. I'm Lisa, and thank you for that nice introduction. Thank you for having me here. I'm really excited to be here. This is maybe the geekiest group I've ever spoken to, and that's saying something. I think some of you have already discovered how absolutely little I know about actually observing the sky. I know a lot about space, but my knowledge in your knowledge areas is really limited, so I think that we can have a lot to say to each other. So first I'm going to tell you a little bit about myself and about how I got into science writing and my career, and then I'm going to walk you through step by step the like pretty minute details of how a particular news story came about. I probably, like many of you, was a kid who loved space, so I decided I wanted to be an astronomer when I was about 8. I observed, I got my first telescope maybe when I was 9 or 10 to look at Comet Hale-Bopp, and when looked at meteor showers and so on. And so my enthusiasm for space took me through a undergrad degree in astronomy at Cornell. This is me, I don't know, I was 19 or something, and this is the 25-inch reflector at the Hartung-Boothroyd Observatory in Ithaca, and I had just gotten a new CCD, sorry, the year that I took the class, but it was so cloudy that semester that I had to use data from that had been taken the year before for some of my projects, and that was too bad, but I really enjoyed my needs there. And I also, in college, worked on the Mars rover, Spirit and Opportunity, landed the year that I began college, and I worked in the Mars lab processing images from the Opportunity rover, many of which look like this. This is the rock abrasion tool, or the RAT, made a hole, so I looked at rat holes, trying to figure out what they were made of by extracting some spectra, what kind of rocks were there. And I got kind of bored with it. I thought that this was going to be a dream job, and it turns out it's really tedious. That's fine, but I wondered what else I could do, and I started writing for my college newspaper, for the Cornell Daily Sun, and decided I really liked that. And I went to, Cornell Daily Sun first, and these are all the other publications that I've written for. I went to UC Santa Cruz. They have a graduate program in science communication that's specifically for recovering scientists. And all I think I was the only one. I was the only astronomer in my year, but the director of the program at the time had an astronomy background too, so that was cool. And then I had my first big kid job at Wired. I was at New Scientist for 6 years when they had an office in Waltham and then Cambridge. So that's what brought me to the Boston area. They're not here anymore, which is too bad. But and then I got a job at Science News, still again writing about astronomy. I started at New Scientist writing, and I edited for a couple of years, but decided I wasn't done writing. So Science News offered me a job to go back to writing, and I took it. And I've gotten to go to some extremely cool places as part of my reporting trips. I took a trip to the Compact Muon Solenoid. It's part of the Large Hadron Collider at CERN. In 2013, they were upgrading it, and so they opened it up, and you got to see its guts. And I was on a journalist trip there when the Boston Marathon bombing happened. That's where it was. So that is very memorable to me. That was a weird trip, but the LHC was really cool. I also got to go to Alaska with a group that was testing a robot that they want to hopefully someday send to Europa to melt through the ice and swim around and find the aliens. Alaska was gorgeous. I camped on a glacier. It was really cool and a little bit cold, and the biggest mosquitoes I've ever encountered. And it was June, so there was no darkness. I brought a headlamp. I was like, of course I'm camping, and then I didn't even need it. And I saw the 2017 eclipse with a group at the top of a mountain in Wyoming, and that was my first eclipse. I saw the one this year too. Did you all see both eclipses? Everybody here? Yes, awesome. Yeah, they're spectacular. It's amazing. One of the coolest things I've ever seen. And I have pictures of the setup of the group I was with. They had solar telescopes, and they had a whole a tent, and the whole entire. You would have been really interested in that. They didn't get to include that, but oh well. And then I also got to go visit the lab at in Houston at the NASA Johnson Space Flight Center where they keep the moon rocks. And I had to put on. I find this picture really interesting now. This was 2019, and I'm in this whole head-to-toe bunny suit, but I'm not wearing a face mask. And that looks really weird now. I don't know what they do now, but they wouldn't let me touch the moon rocks. And so the story I'm going to talk to you about today is this one. And I chose this story partly because Betelgeuse is an easy and common observing target. I bet you're all familiar with it. You probably look at the things in and around Orion. And it was... Did any of you hear about this story? Did you hear about Betelgeuse possibly being a binary? Did this filter to you? Cool, okay. This little blurb is in the November 2nd issue of Science News. And this version is 150 words. It's what's called the front of the book kind of a story, where we have these different sections for little bite-sized newsy items. And the story started life as a paper on the archive, which is some of you are nodding, great. It's a arxiv.org, and it's a server where astronomers upload papers before publication. It's a fantastic resource for journalists. It's a treasure trove. Low signal to noise, but the signals are good. So I saw this paper, and things I look for in paper titles and abstracts when I'm looking for new stories are things like something new that has just been discovered, or a first, or largest, brightest, most energetic, other ests. Anything that sounds like this runs counter to the existing paradigm. Certain topics get a bit of extra attention depending on what's zeitgeisty, what seems to be hot. There was a little while where in 2009 through 2012, where every new exoplanet was its own story. That is no longer true. There's too many now. And I'd actually love to hear what topics you guys are attuned to and what you think I should be writing about. That would be very, come talk to me afterwards, it'd be super helpful. This one jumped out at me because I really love Beetlejuice. I've been on kind of a, did I not include the slides? I thought I did. Oh well. I've been kind of on a Beetlejuice kick for the last couple of years because, maybe it's the next slide. Yes, okay. I wrote a feature about Beetlejuice a couple years ago when it started dimming and everyone thought it was going to go supernova. And I was on maternity leave when that happened, and when I came back to work, I started gathering papers that were trying to explain what was going on with it. And there were too many of them to have just a single little news story, so I ended up spinning it out into a bigger feature. And some of them disagreed with each other. And since then, I've had a lot of affection for Beetlejuice. So I was interested in that story. And then I'll go back a slide, because these are some other places that I look for stories. It's, many journals. And sometimes I get press releases from institutions. And I said I would talk about the difference between press releases and journalism. Is that, do you know what the difference is between press releases and like a journalistic magazine article?
It's a big one question, the difference.
Okay. I think the main difference is like the purpose of a press release is to kind of advertise the work of the institution that you're at. So the people who work at the CFA here, they have a couple of press officers, and if the Chandra Telescope or Hubble or something that is operated out of Hubble's not operated here, but something in your purview has a cool result, you write it up in a way that says like, this result is really cool, and also make sure our scientists did it, and then that's the sort of thing that you can like show to funders and say, we get attention for our stuff and we were doing public outreach and please give us more money to keep doing science. And what I do is not really like that. I like to think that I do less PR. A lot of stories end up being just like, wow, this is cool, and it does kind of give free advertising to the institutions and the telescopes and the scientists who do it. That's okay. But I also almost always include like an outside comment from another person who was not involved in the work to kind of do a little miniature peer review within one story. And I don't know, I feel like it's different thinking that my job is not to promote anybody. My job is just to say, this is cool science and I'm going to explain it to you, and also put it in context and like what this means for astronomy, what this means in the broader world. There are a couple journals that have an embargo system, which is you agree ahead of time to not write about it until a certain time, until the paper has been published in Science and Nature, are the big ones. And then they give you the paper before publication so that you can start writing your story and then have it ready to go when the embargo lifts. So I don't know if you've ever noticed that everyone seems to have the same stories, same science stories at like 1 p.m. on Wednesday or 2 p.m. on Thursday. That's because those are the embargo lift times for Nature and Science respectively. So that was a whole, before I started doing this, I didn't know that was a thing. It's kind of an interesting machinery. I love going to conferences. Sometimes scientists send me their work directly. I love that. If any of you hear about anything, or actually if there's like a new, if a variable star starts doing something, if something goes supernova, if there's a new comet or a new near-Earth asteroid, I would love to know about that too. Okay, this is my affection for Beetlejuice. So the next thing I did was first thing I did was I pitched the story to my editors. This is my pitch email, the actual email that I sent to my editors. Pitching can work in a lot of different ways at different publications. Usually it involves an email or something written down so that the editor and the reporter agree on what the story is going to look like afterwards. And we're sure we're on the same page there. And then we have it in writing to refer to if it goes off track. The template that we use at Science News has a bunch of questions. What's new? Why do we care? Are there any caveats? What else should we know? How should we cover it? Have we covered something like this before? Editor says yes, and we set a deadline, and I start reporting. my reporting process goes something like as follows. I read the paper. Not every science journalist actually reads the paper, but the good ones do. Because there's stuff in the paper that's not in the press release, and sometimes the angle in the press release isn't the angle I want, or sometimes it's wrong. I just, I need to confirm everything for myself and make sure that I understand it. And then I call up the lead author, usually, or the corresponding author. This is Morgan McLeod. He works here at the CFA. Then I interview him, ask him. My first and last questions of almost every interview are, what's new? What's the new thing here that we didn't know before? And my last question is there anything you would have asked yourself if you were doing the interview? In between, I ask more specific things, and how did you do this? Why does it matter? Why should my editor, who doesn't really know much about space, care? Why should, my uncle care? I don't usually ask stuff like that, actually. Sometimes I kind of try to hide from my sources that I actually have a physics and astronomy background, because if you get, they start talking to me in physics instead of in English, and then I have a nice fun science conversation, and then I go back and look at my notes and I have no usable quotes. So sometimes I start the conversation being like, oh yeah, tell me more about that. Oh, what does that mean? Can you rephrase that? And then only later be like, okay, so here's the, but I actually did read your paper and I do know what you're talking about. And then I get outside comment, like I said, from somebody who was not involved in the story, or in the research. Also, in reporting this one, I learned that there was another totally independent group that had a paper on the archive like a month earlier that came to a similar conclusion about Betelgeuse having a companion, so I had to include that one too. So the story got a little bit bigger. News stories like this are actually pretty formulaic. You have the lead, which is like a clever intro. I'm actually gonna grab my water bottle. This was coming out around when the new Betelgeuse movie came out. So I think that's the lead that we went with, was Betelgeuse, Betelgeuse, but that's not the first one I suggested, apparently. And you have what's called the nut graph. Journalists love misspelling things. You'll see lead is not spelled right. Graph, we spell Graf. I'm not sure why. This is the journalist jargon. The nut is just what is the news. It can actually be multiple paragraphs. It can include the quote, but it must include the what is new here and where the result came from. Some background and context, methods, what the team did to get the result that they did, how did they do it, any caveats, and outside comment. And that's kind of, for a relatively short news story like this, it's supposed to kind of go quick, and it's just based on one or two papers. I don't really have to think about it that much. Oh yeah.
I just have a question about the outside comment.
Totally.
Because I always see, you go off and talk to some scientist who was not an author of the paper.
Right.
What is the real point of that? Just that somebody else read the paper and they think it's good work, or?
Yeah, or if they have other comments or concerns, or if they disagree, it's especially interesting. Or if they have an idea for following up on it. But I think the point of it is to not be doing just PR, I think, is to establish a little bit.
Is it like a mini peer review?
Exactly. Which I feel is especially important for things that have not actually been through peer review, like archive papers. Next thing we do is edit. This is the actual Word doc with all the markings from my editors. At Science News, my stories go through 2 edits usually. They go through first one with 2 different editors, kind of just to make sure that we catch everything and have 2 different sets of eyes on it to see if the first editor was like, yeah, that all makes sense, and the second editor is like, no, I have lots of questions, then people have different perspectives. It's helpful. Yeah, here, Haley's saying, not sure this makes sense. And that process actually doesn't really take that long, but. And then we publish the story, and this is how it turned out. You may have noticed in my Word docs that the blurb I had at the beginning had 150 words, and those Word documents I shared had way more than 150 words. So the story first went online. This is a screenshot of the webpage version of it. And then later was cut down to put it in the print magazine. So that happens that way at a lot of places now, that like you have to put stuff online first. And then only later, because your magazine comes out every other week or maybe every month, and then how do you make things seem new if it's been a month since the paper came out? And so the magazine version is sometimes a little bit different than the online version. Okay.
One more,
Okay, and I wanted to talk a little. Oh yeah, another question.
just one more.
Yeah.
What was the delta in time between, your pitch and it appearing on the web?
4 days.
Wow.
Yeah, I think it was within the same week. Yeah, that's pretty normal. Some places go a lot faster, and some places just rewrite press releases, and that's how they do it so fast. But some places are, like New Scientist was a lot faster than Science News actually when I was there. I feel like the cadence was pretty quick. I just wanted to have like one more downer of a slide about the challenges facing journalism in our times. Yeah, misinformation and hype. Trust in journalism is low and sinking, and I'm not totally sure what to do about that aside from just like fact-checking everything, just being truthful, but it doesn't always come across like people. It's truthiness, yeah. How do you know which news sources to trust? How does anybody know? How do the readers know? AI is going to be interesting. There are already publications that are like writing headlines with AI, and we had a survey of our readers about like what they want to know about how Science News is using AI in our journalism. And our readers are great, and they were like, we would like to know everything. We want to know exactly what you're doing, and also please don't do anything with AI. Please just write. And we were like, great, that's what we're planning to do. But we do sometimes, like, there are transcription apps that like I record an interview and then I don't want to sit and type it all out myself. And there are there's a program called Otter, and there's another one called Alice, and those are AI, and they sometimes do very funny things with like the technical terms. I can't think of one right now, but yeah.
AI can do a business where I find it hard to believe it can do factual science.
Yep, it can.
Okay.
It makes stuff up. It does. It makes stuff up. It like, they're like actual things. Like you can tell that some papers have made up the citations. Like they'll refer to papers that don't exist, but they sound like they could be real papers. And that's the sort of thing that AI can do at this point. I think it could get better though. Like I think it is getting better. I don't know exactly where the point where the curve meets what I can do, but. I don't know. I don't know what AI is going to do at our jobs, but I do know that I don't trust it yet because I have seen it get things very wrong. I asked ChatGPT to like write a biography of me, and it was like, Lisa has worked at NASA and all this stuff, and I was like, no, I didn't. I wish, no. And yeah. So that's, I don't know. I don't know that is a challenge that we're facing. We don't know exactly what to do about it. Yeah.
Do you see any of your articles like poached and appear?
Oh, totally.
Instagram or other, like, most people,
Yep.
a lot of young people get their news, not from Science News, but from.
Well, Science News has a TikTok. Like we're on TikTok, we're on Instagram, we're on Facebook and Twitter and Blue Sky, and yeah. Again, that's another part of it, that like we want to be meeting readers where they are, and we want, a age diversity and all other kinds of diversity in our readership.
So do you have people at Science News who take your article and then sort of transcribe it to these other platforms? You don't do it personally?
I write tweets, like I write some like social media copy as a, like, here's a suggestion for when we share this story. Usually I just take like a catchy quote from the researcher and I'm like, here, just use this. But yeah, we do have at least 2 people whose job it is to think about how to present things in social media and like who speak social media.
Yeah.
We're like more denizens of the different sites. And then, newspapers are closing all over the place and there are layoffs and like we just don't exactly know how to make money as journalists if we ever knew how. It isn't working anymore. This has been a thing since I graduated from Santa Cruz in 2009. It was right after the financial crash, and newspapers have been dying since I joined the field, and I don't know, it's been like a pants on fire situation the entire time I've been here, and I feel like I don't know how hot it is. I'm a frog in a pot. So that's tricky. Yes.
It appears the trend has been that wealthy people have to buy the old newspapers.
Yes.
For instance, Jeff Bezos owns the Washington
Yep.
Post. John Henry owns the Boston Globe and
Yep.
the Boston Red Sox. Prior to that, the New York Times owned the Boston Globe. And before that, it was the Taylor family for about 100 years.
Yeah.
So that was the evolution
Of the Globe.
yeah,
Yeah.
big newspaper, city newspapers for a long, long time. Most of them.
Yeah, another one, right now.
Oh.
So, yeah.
Do we have any more slides? There we go. Okay. Now I'll open it up to questions. Yes.
So first a comment and then a question.
Sure.
You mentioned about people not trusting journalism. It's also true that people don't trust science.
Mm-hmm.
And I'm actually interested in your comment about that, but my other question is, what percentage of your articles are not based on a peer-reviewed article? And how do people know?
You mean like what percentage are from the archive or from like a
Or just like
talk
an announcement, this happened, and nobody's actually written a paper to Nature.
Yeah. I don't know what percentage.
I mean, is it common, is it uncommon?
It is common, yeah. No, it's common. Like I was at a meeting for the 25th anniversary of the Chandra Space Telescope last week in Boston, and I wrote a story from a talk that was presented there that there is a paper that has been submitted, but it hasn't been accepted yet, and it exists, but it's not out, so I couldn't. So at the, I should have included this in one of my slides. At the bottom of every story, we have a citation that can point you to the paper that the story was based on, or the talk, or the archive post, or whatever. So that's one way that people can tell. And I always say where it came from. So this was presented at a conference, this was published in Science, this was published on the archive. And I don't think we usually say, I think that we assume our readers know the archive, which, because I kind of have a special readership who's like self-selecting and they already, they're here because they know science a little bit already, but, yeah. Yeah.
So this is a question about publications, about Betelgeuse.
Oh, great, yes.
Research. If the companion star exists and it's in the outer atmosphere, would the period be gradually slowed down as it spirals in?
Yes.
Oh, is evidence for that?
I don't know if there's evidence. I don't think that the baseline of observations is long enough to know, but that is something that they'd expect.
Okay,
Yeah.
that'd be interesting.
Yeah.
Would it slow down? Yeah.
It's dragged from the outer atmosphere, so it should spiral in.
It should get closer and closer, so the period would speed up.
Maybe it wouldn't be falling faster.
Yes.
Yeah.
It's dragged.
What is the target age group or education group, or how do you?
Yeah.
The audience?
I think the Science News audience actually we have a companion magazine called Science News Explores, which is aimed at like 12 through 17-year-olds, maybe 10-year-olds, so like middle through high school students. And they take a lot of the same articles and modify the reading level so that they're a little bit simpler and easier to follow. And they also do some of their own stories and their own reporting. So a lot of my stuff turns into Science News Explorers stories too, and that's fun. So if you have like kids and grandkids and you're looking for holiday present ideas, that's a really good one. But for the grown-up version, I think a lot of our, I mean, I said this before, that our audience is people who are already interested in science, so I don't feel like I have to convince them that this stuff is interesting. I feel like if you're here, you already have bought into space being cool. And the age group is all ages. Yeah, I think our readership has, historically kind of skewed older, and we have a lot of retired engineers and a lot of scientists reading stuff outside of their own field of expertise. And again, with the TikTok, we're trying to, make ourselves sustainable by reaching younger audiences now so they keep reading us.
So a question on the picture that you have with Beetlejuice.
Yeah.
How was the decision made to orient it that way?
Oh boy. I just pulled that picture from the, Getty Images or something.
I'm debating whether you do it so it's good for everybody. It's sort of almost on its side, but.
Yeah.
It's upside down, actually.
Look for the southern hemisphere.
No, I understand.
We had a reader question, actually. I think I said the Beetlejuice is Orion's left shoulder or something. We had a reader question that was like, wait, isn't it the right shoulder? And we were like, well, if Orion is facing Earth, then it's one way, but if it's facing away from Earth, it's another.
If you're in the southern hemisphere, that's what it looks like.
So that picture was taken from the southern hemisphere.
So did the editors make that decision, or did you make the decision for that photo?
The art department made the decision, but I suggested stuff. I'm supposed to suggest, here's some possible art that we could include with the story. Sometimes there's an illustration, one of the, it's a trivial to go back. This one was an illustration we made in-house, I think, of the what they thought that was happening with the dimming event was that Beetlejuice erupted and spit out a big cloud of material, and then it cooled and became dust, and the dust was what was blocking the light. So that's the verb that Beetlejuice did. So sometimes we make our own graphics, sometimes we borrow stuff from the internet. I think space is easier to illustrate than a lot of other beats because there's so much that's in the public domain and it's so pretty. Yeah.
Well, the science news, I would say, is also for people who want shorter articles.
Sure, yeah.
As opposed to Scientific American or.
That's true, yeah. Our longest features are maybe 6 pages. Yeah. I think the longest thing I ever wrote was 7 pages. It was 7,000 words, yeah.
Kelly has a question.
Somebody on Zoom has a question.
Kelly?
Hey, Lisa, great presentation. In your list of challenges to journalism and science journalism in particular, you want to address, please, science literacy?
Yeah. That is also a challenge, boy. And address it how, aside from acknowledging that you're right?
Well, I mean, for example, the National Academy of Sciences has for decades had an annual sort of science literacy
survey
and factor, and it's been going down and down and down. So I, like you, we write for a scientifically literate audience that is getting smaller and smaller, older and older, and so TikTok and Instagram and such notwithstanding, you find that our writing is reaching the next generation, and are they eating it up?
I find it hard to tell. Yeah.
I think what he's saying is the space race generation is aging out.
Well, we're kind of in a new space race now, so maybe that'll get. Yeah, no, we're already there.
But are younger people interested in the fact that there is a new space race this time with China?
I think so. And I think space is a little bit of a special case within science literacy because everybody loves it. Everyone has a relationship with the sky. You know this, but people love black holes. People love the search for life. Even it's this might be changing, but it's even been a bipartisan issue for the past 70 years. That space is just nice, and everybody seems to think it's interesting on its own, and it doesn't take as much convincing, and it's not as controversial as vaccines or other public health things. So, and I think it's kind of a gateway science in that way, that people get interested, this is still true, I think. It was true when I was a kid, and I do think it's still true because I talk to classrooms sometimes too, that people get into science in general through an initial interest in space.
Well, if you look at our particular little niche
Yeah.
and look at the membership of the club,
Yep.
It's growing. It hasn't aged out. It's growing. We have a lot more members than we did 20 years ago.
That's fantastic. That's great.
The average age doesn't change.
Editorial role before you went back to writing.
Yeah.
What kind of editing were you doing? Because I think like most of the job descriptions I see come up that are like the editing that's more to do with like dictating magazine content and types of stories and stuff, but then the editing you showed there is like,
oh,
what I think of more editing.
It was both, yeah. Yeah, I edited the physical sciences news section at New Scientist, and so I was in charge of deciding what we covered, and then other people wrote it and then sent it to me, and I would edit it and cut it down for the magazine. And I also had to think about things like, you know, what's the balance of stories that we have? Do we have 4 stories about Mars and nothing about particle physics this week? We should probably shake it up. And yeah, and like working with writers. Yes?
And do people in those positions tend to be writers first and then they just kind of graduate into the editing?
They do tend to be, yeah. And yeah, it's sort of like, there's not really much of a ladder in journalism. It's like, if you want to get promoted, you have to become an editor. And if you don't like editing, like not everyone is an editor, and not everyone, you know, people do seem to have a preference for one or the other. I like writing, but mostly I really like talking to astronomers, and that was what I missed most when I was editing, was like I wasn't touching the actual stuff as much, and I didn't get to call people. Yes?
When you showed that paper with that story that had been edited by your editors, do you ever get to push back against changes like that?
Yeah.
And is their astronomy expertise better than yours?
No. That's one thing that is special about my role at Science News. This isn't true at every magazine, but Science News has a bunch of beat reporters who are subject matter experts in their beat. So our virology reporter has a PhD in virology, and we have several PhDs. I do not have a PhD, but so I'm the astronomy person, and they generally trust my my news judgment. I actually am backtracking that because one of our news editors does have a PhD in astronomy, and sometimes when the other editors have questions, or if he has questions that I can't answer, then I have to go back to the source. And actually, that happens with any editor too. That if they have a question I don't know the answer to, I'll go back to the paper, or I'll write back to the researcher and find out or figure out how to explain it.
Any questions?
What do you want to see stories about?
New equipment's always exciting. What different agencies are working on, capabilities, even if they're not making it what they wish they had.
Yeah, she's
nice.
It's always interesting to read.
Do you cover much citizen science?
Mm-hmm.
Science news?
Yeah.
That's what I found pretty.
Okay, good to know. Cool. Yeah, I enjoy this. Where should I look for more?
right here.
Right here? Yeah. Can I get on your list? Yeah.
Do lots of articles on light pollution.
Light pollution, yeah. Yeah, that's good, yeah.
Thank you.
Just got an announcement about an hour ago. There's a nova erupting in the Andromeda Galaxy. It's N31N 2008, 12. I've been following this one for 10 years. It erupts about roughly every 13 months. Anyways, it just went out. I'll try to get some pictures of it. But it was interesting. Unlike Len, I'm going to follow a nova, or I'm going to follow it in a different galaxy.
Otherwise, it's too bright to look at.
Okay. Will you send me, some of those photos for?
I think we have come to the end of the meeting, so next meeting is January 9th, 8 p.m.